or at least for those that are not here or those that want to review. So, task number 1 on your performance test final. Draw a line through the points -6, 1, -6, 1, 2, 3, 4, 5, 6, and 1, and 6, -3. 1, 4, 5, 6, 3. There's 1 point. Okay. Find the slope of the line. Slope equals change in y over change in x. So -3 minus 1 over 6 minus -6 gives me -4 over 12, which is -1/3. Always reduce your fractions. Change in y over change in x. Extend the page so I can scroll up. Write the equation of the line in slope-intercept form. So I don't start in mx plus b. Although, well, if this was a better graph, I probably could. Because I graphed it with a line and it goes right through a nice point, but I never want to rely on that. I always use y minus y coordinate. And let's see, I'm going to pick one. Let's do 1 and -6. Y minus 1 equals your slope times x minus the x coordinate. Y minus your y coordinate equals your slope times x minus your x coordinate. Solve for y. Change that to +6. Y minus 1 equals -1/3 x. Distribute the -1/3. -1/3 of 6 is a -2. Add 1 to both sides. And I get y equals -1/3 x minus 1. Okay. And this is why I say don't go by the y-intercept on the slope on your line that you graphed. Go by what you do algebraically. This doesn't go through. Now, granted, like I said, when I made up the answer key, and I did it with a nice ruler very carefully, it did go right through -1. But you got to be really good at graphing. I got a big fatty marker. I'm not using a ruler on here, so you kind of get what you get. Now, the next one, and this seemed to be the one that most people had a problem with. Rewrite the equation of the line in standard form. To write it in standard form, I need to get rid of any fractions and put the x's on the other side. So here's what you do. I want to get rid of the 1/3 x, so I take this existing equation, multiply everything times 3. Why 3? Because it's a 1/3. Get rid of the common denominator. 3 times y gives me 3y. Equals 3 times -1/3 x gives me -x. 3 times -1, -3. No fractions. First step. Second step, x, y equals number. So I got to move the x's over to the other side. I add x to both sides. Three times -1/3 x.
Yeah. Okay.
So I end up with x plus 3y equals -3. Standard form. So I get to the next one, go back to the coordinate grid A above, and draw another line perpendicular to the first line through the point 5, 4. First thing I do is I'll locate the point 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then the slope of this line is -1/3. So the slope of the line perpendicular would be +3. Opposite, inverse. Flip it over, change the sign. +3 over 1 up 3. That's my line. Now I have to come up with the equation. I do the same thing I did here, only with the new point and the new slope. Y minus my y coordinates 4 equals 3, my new slope, times x minus my x-coordinate. Distribute and solve for y. Y minus 4 equals 3x minus 15. Add 4. Y equals 3x minus 11. Now, put it in standard form. First step, get rid of the fractions. I don't have any fractions in this one, so I don't have to multiply through by the denominator to get rid of the fractions. All I have to do is take the 3x, move it to the other side, which means I subtract 3x from both sides. And I get negative 3x plus y equals negative 11. Okay? Questions? Yes? Yeah, I don't mind negative in standard form. If you wanted to, and I am smart enough to recognize that if you make the x positive, because I know some teachers get all in a wad over, oh, it's got to be positive x's. No, it doesn't have to be positive x's. Some textbooks get all worked up over it being positive, some don't. I don't care because it really doesn't matter in the long run. But if you wanted to, you could do that, and you would have 3x minus y equals positive 11. Either one of those would be okay. Does that make sense? Either one of those would be fine. I'm good with either one of them, and I'm smart enough to recognize that, oh, it's the same thing, only everything signs changed. Okay? Like I said, some textbooks, oh, the x's have to be positive, and some teachers, oh, the x's have to be positive. Some of us don't really care. It's kind of, it's one of those gray areas. And some are really strict about it, and some are like, hey, it's x's, y's equals number. That's what I'm strict about. And no fractions and no decimals. Okay. Any other questions on this one before we go to the next one? Okay, next page. Okay, sketch the parabola with a vertex of negative 3, 1, going through the point negative 2, 2, and negative 5, 5. First thing you do is you plot the points. And the vertex is the most important one. By the way, online, those points were cut off. I fixed it, so if you go back online and print up a new blank one, they're fixed now. I don't know if anybody looked, but these points were cut off for some reason. Negative 3, 1, 1, 2, 3, 1, it's right there. Going through negative 2, 2, negative 2, 2 is there. Negative 5, 5, negative 5. 5 is right there, and I go like this. What is the value of the y-intercept? Going to come back to that one. Is it already done? It's already done all right. You were given 3 points on the parabola. State one more point, x, comma, y, on the parabola other than the y-intercept. So I'm going to come back to that one too, and you'll see why in a minute. State the equation of the axis of symmetry. It's x equals the x-coordinate of the vertex. Okay. State the vertex form of this parabola. X minus the x-coordinate of the vertex squared plus the y-coordinate. So I get x plus 3 squared plus 1. State the standard form of the parabola. In other words, take this, square out the x plus 3 squared. So I take x plus 3, square it out, add 1. X plus 3 squared, x squared plus 6x plus 9. Add 1 to that because I don't forget the 1. A lot of people squared out the x plus 3 when we did this test. Forgot to add the 1. X squared plus 6x plus 10. Gentlemen, your grades are not such that you can afford to ignore this. Okay. Now, why did I say these two for last? Because they're very easy to get from the equations. Okay. The value of the y-intercept. The x-coordinate equals 0. On the y-intercept, x always equals 0 on the y-intercept. So I plug in 0 for x, and what do I get? If I put 0 in here, 0 plus 3 is 3. 3 squared is 9, plus 1 is 10. If I put 0 in here, this goes away, that goes away, I get 10. So my y-intercept is 10. Okay. Technically it's the point 0, comma 10. Now, okay. When you do the last one, 3 points, here's what I always say to do. Pick some coordinate other than this one, or that one, something other than x equaling 0, -3, -2, or 5, and plug it in. Because there is technically an infinite number of answers to part C. Pick some x other than the 4 that are already given, plug it in, and figure out what y is. 1. Okay. 1 plus 3 is 4. 4 squared is 16. 16 plus 1 is 17. 1, 17. You can put in -1. -1 plus 3 is 2. 2 squared is 4. 4 plus 1 is 5. -1, 5. It's infinite number. It just can't be one of the 4 already done, the y-intercept or the 3 points that I gave you. So technically, there's an infinite number of solutions for that one. Okay, or answers to this. And if you pick something really hard for me to check on you, I'll be very unhappy, and you don't want me unhappy while I'm grading your tests. So don't pick X to be 100.3526 and plug it in. I would be very displeased with you. You don't want that. Last one. Our 3 friends, Kelly, Chris, and Sam, once again delivering flyers. Kelly, Chris, and Sam are delivering flyers in Placerville neighborhoods to promote their lawn care business. Working together, they can deliver 280 flyers every hour. Kelly and Chris can deliver 189. Kelly and Sam, 195, using K to represent the number of flyers Kelly uses. C to represent the number of flyers Chris can deliver. S to represent the number of flyers Sam can deliver. Answer the questions below. So K, C, and S are our 3 variables for Kelly, Chris, and Sam. How many flyers can they do together? Total. 280 flyers total. So that means K plus C plus S equals 280. Kelly and Chris. K plus C. How many can Kelly and Chris do? They can do 189. 189. And then how many can Kelly and Sam do? Kelly plus Sam is equal to, Kelly and Sam can do 195. 195. Now you have a system of equations because you've got 3 variables, 3 equations. How many can each one of them do individually? Now, if you wanted to add 2 together to try and eliminate a variable, blah, 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 you can do that. This one's really easy. This one's really easy. Take the top equation. K plus C plus S equals 280. From that, subtract one of the other 2 equations. K plus C equals 189. Subtract. The K's cancel, the C's cancel, you get Sam, and then you do your subtraction and you get how many Sam could do. Let's see, that's a 7, we did 2, that's 1, 7, oh, can't do that, 1, 7, make that 17, 91. So Sam could do 91. Piece K. Which means that Kelly plus 91, which Sam can do, equals 195. Subtract 95 from both sides, and you can get Kelly can do 104. Subtract 91, sorry. Subtract 91 from both sides, and you get 104. And then go back up to this one. Kelly, which we figured out can do 104, plus Chris can do 189. Subtract 84 from both, 104 from both sides, and you get 85. So Chris can do 85. There you go. Piece of cake.